Imagine standing at the edge of reality itself. You stare into an invisible wall, a boundary written by the laws of physics, one that should be unbreakable. And yet, in the strange quantum world, particles slip right through these barriers as if reality itself is full of cracks, loopholes, and hidden escape routes. This mysterious phenomenon is called quantum tunneling, one of the strangest, most mind-bending processes in science. It is so bizarre that it not only keeps stars like our sun burning, but also threatens the stability of the entire universe itself. In our everyday world, the rules feel solid. If you throw a ball at a wall, it bounces back. It doesn't magically appear on the other side. But in the quantum world, particles like electrons don't behave like tiny billiard balls. They are clouds of probability, waves spread out across space. And when these probability waves slam against a barrier, there's always a chance, small but real, that part of the wave seeps through. That seepage allows the particle to appear on the other side, almost like a ghost slipping through a locked door. And this isn't theory, it's reality. This is how the sun fuses hydrogen into helium. By all rights, that reaction shouldn't happen at the sun's temperature, because the energy required to force protons together is far greater than what's available. But tunneling allows those protons to cheat, to squeeze through barriers that should repel them forever. Without tunneling, stars would never shine, planets would remain dark, and life would never have had the chance to emerge. Already, every breath you take, every moment of sunlight warming your skin is powered by impossibility, by particles refusing to obey the rules. But tunneling doesn't stop with the sun. It underpins the very ground beneath your feet. Radioactive decay, the process that keeps Earth's core hot and drives volcanoes and plate tectonics, is also the result of tunneling. Inside unstable nuclei, alpha particles should remain trapped forever, yet they escape, tunneling through the nuclear barrier. This decay not only warms our planet, but also seeds it with the elements necessary for life. Gold, uranium, even the carbon in your body, all of it owes its existence to tunneling. The fact that you exist at all is tied directly to this tiny, improbable quirk of physics. But as much as tunneling sustains life, it also carries terrifying implications. Because if particles can escape through impossible walls, then perhaps even the universe itself could one day tunnel out of existence. Physicists call this possibility vacuum decay. Imagine a universe that suddenly tunnels into a lower energy state, rewriting the laws of physics in an instant. In this nightmare scenario, everything you know, atoms, stars, galaxies, even time itself, would collapse. The destruction would spread at the speed of light, unstoppable, invisible, and absolute. This isn't wild fantasy. It's written into the mathematics of quantum field theory. The Higgs field, the invisible force that gives particles mass, might not be perfectly stable. If it isn't, then the seeds of annihilation are already here, somewhere in the invisible fabric of space. We may live in what scientists call a false vacuum, a fragile bubble of reality that could burst without warning. No sirens, no signs, just the end. And yet, while tunneling carries the weight of doom, it is also deeply useful. In fact, we already harness it every day. The transistors inside your smartphone rely on electrons tunneling through barriers to make microchips smaller and faster. Scanning tunneling microscopes, machines so precise they can image individual atoms, exist because of tunneling. These devices sound like science fiction, yet they're part of everyday science labs. And then there's quantum computing, perhaps the most revolutionary of all. These futuristic machines use quantum tunneling and superposition to process information in ways classical computers never could. Problems that would take today's fastest supercomputers millions of years might be solved in seconds. And it all comes down to the same phenomenon that allows the sun to shine. But tunneling doesn't stop at technology. It stretches into the very origin of reality. Some theories suggest that entire universes can tunnel into existence. Our universe itself may have tunneled out of nothingness, escaping the ultimate barrier of non-existence in a single explosive quantum leap, the Big Bang. If that's true, then tunneling isn't just a side effect of physics. It may be the ultimate creative force, the process by which reality itself is born. And if universes can tunnel into being, then ours might not be the only one. Perhaps there are countless others, tunneling in and out of existence like bubbles in a vast quantum ocean. If so, then the multiverse may be real, a cosmic foam of infinite possibilities. Universes rising, collapsing, and flickering like sparks in an endless night. If that's true, then our own existence is nothing more than a brief flicker in a storm of infinite creation. But what does this mean for humanity? If tunneling allows particles to cheat the rules, maybe one day we could too. Imagine harnessing quantum tunneling not just for computers, but for travel itself. Imagine slipping through barriers of space-time, bypassing the ultimate limit of light speed, leaping across the stars not in centuries, but in moments. Perhaps even opening tunnels to entirely new universes, escaping the eventual death of our cosmos, turning impossibility into a roadmap for survival. Still, even as we dream of such futures, one haunting truth remains. We don't fully understand tunneling. We can measure it. We can calculate probabilities. We can even exploit it in our machines. But we cannot explain why the universe allows such rule-breaking. Why does matter sometimes choose the impossible path instead of the expected one? It's as though the cosmos itself was built with hidden trapdoors, secret passages, a reminder that what we see is never all there is. And if tunneling is real, and it is, then nothing is entirely certain. Not the ground beneath your feet, not the stars above your head. Reality itself is fragile, slippery, and built on uncertainty. The universe is not carved in stone, it's written in probabilities. And those probabilities sometimes allow the impossible to happen. So the next time you look at the sun, remember this. It shines because particles are escaping reality. They tunnel through impossible barriers, proving that impossibility is never permanent. Reality is not absolute. The walls of nature are thinner than glass. And beyond those walls may lie truths stranger than we can ever dream. Perhaps this is the key not only to understanding the cosmos, but to humanity's ultimate destiny. One day, we too may step through the invisible cracks in reality. We may tunnel beyond our universe, and there, in the great unknown, we may finally discover what lies beyond.